All of you know there are certain important topics, tools we will be learning today. Can you help me now figure out those topics assigned today? What is the first topic? Are you aware of the schedule or not?
Yes, sir. MSA, sir.
MSA, yes. We are going to talk about MSA. Okay. But prior to that, I think there are a few other topics. Come on, you all have to be active. And I think the schedule has been shared with all of you, right?
Interpretation of control chart using Minitab.
Is it planned for today?
This is day 6, day
Okay.
5. Okay, sorry.
Take
Measurement
five.
system analysis. Yes.
Measurement system
Yes.
analysis.
Analysis.
This is what
MSA.
we'll talk
Introduction
today.
to statistics.
Statistics. Yes.
That is very important.
And
Introduction to statistics.
Statistics.
That is what we should
yeah,
start with
so
today.
yeah. Next is normal
Understand.
distribution and introduction of gauge and R&R and
Very
process capability,
important.
CPCPK.
Excellent. So not only statistics, we need to understand an important theory of statistics. The whole statistics is built based on a theory called normal distribution. That you must learn now. Then only, using the statistical tools, you will be able to relate. And then MSA. In MSA, there are two types of MSA. One is gauge R&R study. Other one is attribute agreement analysis. And then process capability analysis, CP and CPK. So these are the three topics. All are very interesting. I'm sure all of you are equally interested in learning these tools. Am I correct with my understanding? So I want all of you, to be, very active and at least use the reaction button. There is some reaction buttons are available. You can send balloons or you can send, whatever you want, right? There are some crackers available. So please make use of all these things. I want you to respond and remain active. Nowadays, there are a lot of distraction. So you will certainly suffer from all those distraction, I know. So unless and until you are participating here, active here, you cannot avoid the distraction, right? So, and then this purpose will be lost. Okay. So coming to the topic. Good. Statistics. So what is statistics? The science of dealing with the data. Statistics is nothing but the science of dealing with data. All of you, have you ever dealt with data? Are you dealing data for any particular purpose? Definitely, all of you should say yes. Am I right?
Yeah, yes, sir.
All of you, yeah. All of you are using. That means you are already using statistics. And only thing is you should know the science behind. Science is something, which is factual. And when somebody check the findings or the knowledge gained from the scientific study and the test outcome will match. That's what we call scientific approach. Okay. So the science of dealing with the data, whether you collect data or you are tabulating data, you are entering it in an Excel, or you are converting your data into some visuals, graphs, Pareto, control chart, bar chart, things like that, or you are doing some calculation. Let's say you are figuring out what is the maximum out of your data, what is the minimum in your data, what is the difference between maximum and minimum. If I ask you what is the difference between maximum and minimum, do you know what is it called?
Range.
Range. Excellent. The difference between the maximum and minimum is called the range. Range is an indication of the spread of your data. Yes or no?
Yes.
Yes.
How long is the spread or how short is the spread? You get a quick understanding. So anything that you calculate from your data is also called as statistics. Statistics is a science. Yes. We deal with data, etc., and we do some calculation. And each and every calculated value should also be called as a statistic. This range is a statistic. Mean is a statistics, isn't it? Likewise. Why do we calculate all these things? And based on the range, we interpret. Based on the range or based on the statistics calculated, we interpret the facts. The data is trying to convey. Say, for example, I conduct an exam and you all get no marks, and the range is found to be very high. What does it indicate me? If the range is very high, what does it indicate me? The range is very high. What does it indicate me?
Variation is more.
Or I will ask this way. The mean, the average score is very high. The average score itself, is 85. What is this indicating me?
Major of the students have done
If the
well.
average is excellent, majority of the students have, performed well. Because that's why, the average is, very high. But at the same time, come on. At the same time, if the range is very high, what does it telling you?
The
The range is very high. That means some students got, 85, 90, 95. And few students got 20, 25, 10, 15 also. Then only the range is very high. Yes or no?
Yes.
Yes, sir. Yes, sir.
That means there is, inconsistency in your data. The variation is very high. If there is inconsistency, that confirms that there is poor control over the process. Isn't it? Poor control over the process. If you have good control over the process, all of them would have scored, closer marks. If few people are not really, able to score well, unless and until they are outliers. If equal amount of people have scored very badly, then definitely the process itself, is not in control, isn't it? So this is exactly called statistics. We collect data, we tabulate data, we visualize data, we calculate statistics, and finally we interpret the calculated values for effective decision making. We interpret the calculated value for what? For what is the purpose? For effective decision making. For effective decision making. So this is called statistics. And statistics, there are two types. One is descriptive, another one is inferential. Like today, how many candidates are attending the program? How many are like a male candidate? How many are female candidate? How many are working professional? How many are business owners? How many are students? So this kind of information, I just gather and tabulate them nicely and then present it to all of you. And this is called what? Descriptive statistics. Whatever information you observe through your data without any difficulties, that is, you are just understanding the information that is contained in a data in a visible manner, which anybody can understand. And this is called descriptive. You are only describing the features. That is called what? Descriptive statistics. So Virat Kohli is coming to bat. As he enters the crease, ground, you see some statistics being shown. Yes or no? His name will be there, his age will be there, his debut date will be there, his centuries will be there, his 50s will be there, the maximum run scored by him, the average score, the strike rate. Are all these things are statistics or not?
Yes.
Definitely all of them are statistics. By seeing those numbers, can you make out what kind of player Virat Kohli is?
yes, sir.
You can understand, right?
Yeah.
So he's a very, nice, very good batsman, and having excellent average and so on. So, but everybody knows, and there are no more much challenges in understanding the information presented. This is called descriptive statistics. It either talks about the present, or it talks about the past, or it talks about the what do you call directly understandable information. All right. So this is called descriptive statistics. Are you with me, all of you? Do you understand what is descriptive?
Yes, sir.
Yes, sir.
First topic of the content is finished. We understood statistics. We understood descriptive statistics. Can I give one example? Anybody, would you like to give one example, on your field? One example. from your company, from your daily life or whatever. Or I will tell first, the what do you call the programs I conduct every month. Last 6 months data, whatever programs I conducted, in-house training so many, and consulting programs so many, and online trainings, classroom trainings, level trainings, black belt trainings. I give some numbers, right? In a single slide, I present last 6 months. This is what I did. What kind of statistics is this?
Descriptive.
Descriptive, and you could also immediately understand, right? So with by collecting data, I describe present and past, and the information is shared. That is descriptive. And now, based on the data you have seen, what do you think my performance will be in the next 6 months? If I give you my last 6 months performance, will you be able to make out something about my next 6 months performance? Will it be same? Will it be less? Or will it be more? Will you be able to judge? Possible. Possible or not?
Nearby
Yes.
the tolerance, within the tolerance.
Definitely possible. Definitely possible. But you
Some
will
probability.
definitely, you will come up with some plus or minus value, which is called an error, margin of error. It's a prediction you are doing right now. When I ask you about what will be the programs I will be conducting in the next 6 months, or what will be the number of participants in my next batch, I give the record of the number of students in my programs last 6 months, and I want all of you to judge how many candidates will be attending my program next batch. What do you think, all of you? Next batch, the numbers will be more than this batch or will be less? What is your prediction?
We want to see
More, sir.
some 10 data's past history to get.
I'll give you 10
Yeah.
datas. And what do you think, your gut feeling right now, even without, if I don't share the data, what do you think? Will the numbers be more, or is it going to be less? Will there be any, seasonal impact, or will there be any, specific challenges we face? So what I feel is,
Seasonal impact will be there, definitely.
seasonal impact will be there.
Yes.
And what I feel is, month on month we train people, we get more and more alumni. Our network is, ever growing. So there is a good chance that you could refer more people, and the numbers are expected to
Increase.
increase, provided you maintain, the quality in your programs, and obviously they'll refer, right? But still, we can't judge it, very accurately. That is not possible. You can't judge because there are some, variations always expected. It will be plus or minus. You might say, sir, this batch we had, some 60 people or 70 people. So next batch it will be 70 plus or minus 10. Possible, right? And maybe, for some reasons, there can be, additional 10 people you might get. And similarly, we may also get 10 numbers less. So this is called a prediction. If you make use of the available data and then predict the future events, right? Or if you use the data for the purpose of prediction, then your statistics, the predicted values, are called inferential statistics. Are you with me, all of you?
Yes, sir.
Yes.
And you all have your
Yes.
salary data. All of you have your salary data for last 5 months or 5 years. Just type all those values in an Excel column, and then the the typed information is known as descriptive. Last 5 years salary details. And now you want to judge what will be your earnings next year. Maybe you can find out, you can plot the graph and then you can find out. So that way it will be inferential. Any of you, would you like to give any example of descriptive statistics and inferential statistics in your life or in your work, or
So descriptive statistics, we can say the amount of shipment done per month for the last 6 months or 1 year.
Very good.
And i- inferential, we can also do weather forecasting, like weather or the sales forecasting, like for the upcoming quarter or something like that.
Excellent. Very correct. You gave the right example for descriptive as well as inferential, right? Weather forecasting, whether there'll be rainfall, whether there will be, some high temperature expected. All of those things are inferential, right? So you often, I think, you come across both the descriptive and inferential, isn't it? And your production details you display on a board. What kind of statistics that is? Plan versus actual. It's a descriptive, right? So there is a target and then there is actual, and you are just tracking. It's a descriptive. And so, but
Sir, production plan, excuse me, sir. Production plan for today, this is a plan that will be a inferential, no, sir. Production daily plan, we are not giving the past data. Today, we have to produce so much.
today you have
And
to produce.
currently, we are producing so much. That will be inferential. Just please clarify.
No, no, no. Today, this many you have to produce is a target you are setting,
Correct.
right? It's a target.
Hmm.
Yes. And but if you give the number of units produced for the day, then it becomes descriptive. But the number of units that you will be
It is a
producing,
dynamic.
tomorrow,
Hmm.
producing the number of units you will be producing tomorrow will be inferential. Until the day is not completed, but still you expect certain numbers. That way it becomes prediction. That way
Okay.
it becomes inferential.
Yeah, that's
But if the
what.
day is over and the count is, realized, then it is descriptive.
Yeah, correct. Agree.
Right. Very good. And in statistics, prediction always happens, with an interval. Everyone's expectation is you should be able to predict accurately. Predicting accurately means you should find out a value very, very closer to the actual that is going to come.
A
Are you getting my
minimum
point?
error.
Yeah, with the minimum error. And also, your prediction will always come in an interval, and the interval should be as small as possible. Are you with me? For example, Kohli's descriptive statistics I have shown you, but I want you to tell me how many runs Kohli will be scoring in the current match. Current match, still he is going to play. But what do you think? His batting average is 55. Will he score again 55? Can he hit us, 50 today? Sometimes he may go on and then hit the century also. And he can, get duck out also. But looking at the consistency, the chance of getting Kohli, on duck out is very less. Yes or no? You could see him, the past data is telling us. So you can definitely expect him to score 50 plus or minus a margin of error. The margin of error, the lesser the error you add, lower the confidence you will have. Yes or no? Say, for example, if I say Virat Kohli will score 50 plus or minus 2, then I only have a narrowed interval, 48 to 52. 50 plus or minus 2 leads to what? 48 to 52. And getting Kohli scoring in this smaller range, the chances are very less. Yes or no? As the interval is less, then chances will also be less. Are you with me, all of you?
Yes, sir.
Right? So, the interval, the wider the interval, the larger the confidence. Narrower the interval, lesser the confidence. So, what is this confidence? What is this confidence interval? What are the extreme values? Extreme values are nothing but confidence limits. 50 plus or minus 2. The extreme values are 52. This side it is 48. I can call it confidence limit. But in general, I can call it prediction limit. In general, I can call it prediction limit. And there is also another terminology called confidence limit. We'll differentiate, what is prediction limit and confidence limit little later. Right now, let us assume both are same, right? So, Kohli's score in the ongoing match will be 55 plus or minus 10. I am telling you, 55 plus or minus 10. That means it's a prediction interval. That means it is a prediction interval. The upper limit, the upper maximum prediction limit will be 55 plus 5 will be 65. The lower prediction limit will be 55 minus 10, 45. That means I expect Kohli to score anywhere between 45 and 65. Hope all of you understand, no? So the interval what we are referring to is the prediction interval. So now your job, when you are dealing with the data, your job is to predict the values at the same time with a lesser, smaller interval. Smaller interval, but the amount of confidence we want is higher. Do you understand the challenge, all of you? If you predict something and it must happen, the chance of your prediction happening should be very high. That is called, confidence level. So normally your organization will expect a higher confidence on your prediction. At the same time, your prediction should have a smaller interval. Is this clear, all of you? Right? We spoke about statistics. We spoke about descriptive statistics. We spoke about inferential statistics. We spoke about prediction interval. We spoke about prediction limits. There is upper prediction limit. There is also lower prediction limit. Now I'm going to tell an important point. The prediction interval depends on the variation in the data you are using to find out those limits. Prediction interval depends on what? The variation in the data. Tell me, if the variation is too high, what will happen to your prediction interval? Wider or narrower?
Wider, sir.
Wider. If variations are less, then the prediction interval will also be less. And that is, and again, to understand the variation or to quantify the variation, we need to calculate certain statistics. The statistics that are normally used for understanding the variation is, one is range, you already know. The formula is very simple, maximum minus minimum. Another one is standard deviation. Another one is standard deviation. Right? What is standard deviation? MD would like to define this. Simple definition. Standard deviation is deviation from the mean value. What is standard deviation? Deviation from the mean value.
Mean value.
I'm telling you, normally when we conduct the final examination for the participants, the average mark scored by the student is 85. Average mark scored by the student is 85. So now you all know what is our standard, right? The average mark scored by the student is 85. Now, if you all actually write an exam, do you think all of you will score exactly 85?
No.
No, sir.
No.
Definitely, no. You may score 85. You may score more than 85. You may score less than 85. So each one of you will have a deviation from the mean value. Do you understand? Each one of you will have a deviation from the mean value. Are you getting my point?
Yes.
If I also write an exam, I will also be away from the mean by certain distance. Let's say I scored 86. That means I am closer to mean. Another person 95, he is away from the mean. Another person 25, he is far away from the mean. Another person, he is 83, he is also closer to mean. So each one of us will now be experiencing a deviation from the mean value. Hope all of you understand the meaning of deviation. Okay? And now, since there are 50 candidates, there are 50 deviation, we need to standardize the deviation. We need to standardize so that we will have a single value to tell to others. How is this class performing? That is the question. Question is not, how is Kumar performing or how is, Satish performing. Question is not that. Question is how is the class performing. Class has, 50 students. There are 50 marks. So there are 50 deviation. What will I do? I'll standardize that deviation and I will call it standard deviation. How to standardize? Shall I teach you some max now? Okay.
Yes, sir.
Yeah. So I just share my screen. Let's understand little max behind the calculation of standard deviation. But anyway, I already know Excel and many softwares can give the standard deviation easily, but still let us understand ourselves. This will help us in understanding many other concepts. Okay, this is an Excel file. So let me go to a new Excel sheet. Okay, this was standard deviation calculation. Okay, so oh God, the name is already taken. How can this same name can come? Yes. Okay, now it's okay. So see here, let us take X value, right? X can be any data point. And now let us take any easily understandable value. 3, 4, 5, 6, and 7. So how many data points I have taken? 1, 2, 3, 4, 5.
Five.
Very simple.
5.
Just 5 data points. Now I want to calculate the mean. The mean is nothing but X bar. So what is the formula for mean? We have to actually sum all this data.
Average.
Sum by number.
Yes, average. Yes,
Number of-
average. We can use the average, or you can sum divided by the number is 5, and so the mean value is 5 here. Hope all of you understand this, right? Very simple. Mean. The first column, the mean is understood. Now in the next column, we are going to calculate. What is this? Excel is saving this for a longer time. Yeah. So we are going to calculate the deviation, right? The deviation, I'll tell you, X minus X bar. You understand all of you? The deviation formula is what? X minus X bar. Now you please tell me, what is the deviation for 3 from the mean of 5?
-2.
-2.
2.
Minus 2. Then for 4, it is
-1.
-1.
-1.
Then for
0.
5, 0.
0. 1
Then for
and 2.
6, it is 1.
1.
Then for 7, it is 2.
2.
Now I want you to sum up, the deviation. Sum of the deviation.
0.
Sum of deviation. Sum of deviation, you can easily understand. Even if I change the number, the sum of deviations will always be 0. Do you all agree with me? Even if I change the numbers, the sum of deviation can still be what? 0 only. That means when we want to quantify the deviation, is just vanishing in numbers. But actually we could see there is a deviation, yes or no? There is a deviation. Only thing is, when we sum up, it is vanishing. So we don't want to leave it. So what we do is, we'll go for X minus X bar. The whole square. This is called squared deviation now. What is this called? Squared deviation. Okay. Sum of deviation is done. Now we are going for squared deviation. Squared deviation is nothing but this number raised to the power 2. Are you getting it? The number raised to the power 2 will be 4. Similarly, for 1, it will be plus 1.
1.
I'm just dragging it down so you all know. You will get the result. Are you with me, all of you? What is this term called? Squared deviation. Now I'm going to calculate something known as SSD. You know what is SSD? Sum of squared deviation. Sum of squared deviation. So sum of all of these things. How much it is? Sum of squared deviation? 10. And now I'm going to calculate calculate sum of square deviation divided by n minus 1. I should use small n because it's a sample data. Sum of squared deviation divided by n minus 1. That means what is this value? This will be sum of square deviation is 10. N is how many here?
5.
So 5 minus 1 will be 4. Now we are getting 2.5. This 2.5 is known as variance. Variance is how much? 2.5. All of you, do you understand up to this? How did I calculate variance? Am I correct? Now,
Sir, how did we calculate n? Can you explain?
n is number of data point. Number of data point is 5.
5.
So 5 minus 1 will be 4. 10 by 4 is 2.5.
Okay.
Clear? Yeah. Now we are now going to calculate standard deviation. The standard deviation is very simple. Standard deviation is nothing but square root of the variance you calculated. What is standard deviation here? 1.58. Do you understand, all of you? Oh God. I'll share again.
So what is standard deviation? Square root of?
Square root of variance. Standard deviation is equal to square root of variance.
Here square root of 2.5.
Yes. Yes. Square root of 2.5. Now I'm going to write the formula now. See here, standard deviation. The formula is square root of summation of, oh God, x minus x bar, the whole squared, divided by n minus 1. All of you, are you seeing the formula of standard deviation? Under root of summation of x minus x bar the whole square divided by n minus 1. So what is inside the square root? Your variance. What is inside the square root? Your variance. The variance has a numerator part and denominator part. What is numerator? What is numerator? SSD. What is SSD?
Square root of variance. The sum of square the deviation.
I told you, all of you cannot
Sum of
easily
square the
get
deviation.
distracted. You have to sum of
Square the deviation.
sum of squared deviation. I have shown you the deviation. I have shown you the squared deviation. I have also shown you sum of squared deviation. How much is the sum of squared deviation? Tell me. Value for our data. What is
10.
the sum of squared
10.
deviation in our data?
10, no? 10.
Very good. 10.
10.
And there is a denominator. The denominator is n minus 1, which is called as degrees of freedom. Which is also called as what? Degrees of freedom. N minus 1 is also known as degrees of freedom. And so degrees of freedom will be how much? 4. And so it is under root of 2.5. And so if you calculate the root of 2.5, it will be, how much it is? 1.58 or something. So this is the way the standard deviation is calculated. Are you with me, all of you?
Yes, sir.
Yes, sir.
Do you understand? Why am I teaching you the standard deviation? Because if you know the standard deviation, you can estimate the prediction interval. In inferential statistics, we spoke about prediction interval, isn't it? That interval can be judged accurately if you know the concept of standard deviation. Clear, all of you?
Sir.
Yes. So hereafter, if we give any set of data, you will be able to calculate standard deviation. Am I right?
Yes.
Yes.
Any set of data. It can be 5 data point or 10 data point. But normally, for calculation of standard deviation, The sample must be a large sample. If the sample is too less, like, just 5 samples I'm using, in those cases, range is preferred over standard deviation. But when sample is large,
Is
then
there any
standard
minimum
deviation,
quantity?
normally 30 is the thumb rule. 30 is the
Okay.
thumb rule.
Okay.
And yeah, so if you have 30 samples, then calculating standard deviation will be more realistic. That's a point. Okay. So now that we understood, some concept about some statistical values, mean we know. Okay. We understood mean, we understood standard deviation, we understood variance, all of those things. Now I want to talk about, or I want to understand the height of all our participants, right? What do you think will be the average height of our participants? All of you tell me.
We
Am
are
I
seeing
correct?
only face.
5.5? Average height. If I calculate average, will it be 5.5?
Actually, yes.
5.5, right? So 5.5, 5.75, and 6.0, and then 6.25. And this side is 5.25, and this will be 5. Now, please understand when I say, when I choose this bar, it might refer, the interval from 5.25 to 5.5. And this will refer to an interval of 5.5 to 5.75. And this will refer to an interval of 5.75 to 6. And this will be 6 to 6.5. 6 to 6.25. Are you with me, all of you? From
Yes.
yellow to orange, orange to red. The same thing might happen this side also. Why am I choosing, this color? Now, if I ask how many people are having the height around 5.5 feet, I think definitely many people will be having a height around this 5.5. Am I right? Do you agree, all of you?
Yes, sir.
Yes, sir.
People who are having a height around 5.5, I'm just counting, approximately I'm counting. Now what I do is 5.5 to 5.75. How many people will be there? Definitely there can be some good number of people again, but not to the size of the frequency of 5.5, because 5.5 being at the center, there were too many people. What I'm trying to say is, as I move away from the mean, the number of observations are expected to be smaller. Yes or no?
Yes, sir.
Say, for
Yes.
example, if I move far away from the mean, then there will be only fewer observations. Say, for example, how many people within this classroom right now are having a height above 6 feet? Anybody would like to share your height? How many are above the
6'1".
how many?
6'1".
It would be very
Ah,
less.
yes, very less. Maybe out of the 50 people here itself you can find hardly those who are having a height above 6 feet. Maybe you can record it in the chat box. Then what will happen? We may see definitely some few people, maybe 3 or 4 people. So what I'm trying to say is this height, the height refers to the frequency of observation. This height will be smaller compared to the observations you see at the center. Is it believable, all of you?
Yes,
Yes,
sir.
sir.
Similarly, how many of the participants will be having a height lesser than 4.75 and 4.5 to 4.75? Here also the height is expected to be, or the frequency is expected to be smaller. And so in between, you will find proportionately larger values. If I repeat the same on left side, are you able to notice a kind of pattern? What pattern you are seeing here?
Well
Normal
shaped.
Will this
distribution.
Well
will
curve.
this be possible or not? Will this be possible or not? Right now, I checked with your height. I can also talk in terms of your weight. I can also talk in terms of your weight. I can talk in terms of your sugar level, cholesterol level. I can talk in terms of the characteristics of anything. It can be a product or it can be a process characteristics. Any measurable characteristics will demonstrate this property. Any measurable characteristics will demonstrate this property. There are certain conditions to get this normality. There are certain conditions. One is you must have your sample must be very large. Large sample, please understand. If you have very smaller number of sample, then probably you may not be able to see the perfect bell curve. But definitely with the large sample, let's say you have 500 data point, 5,000 data point, and definitely you can expect normality. All of you agree with me?
Yes.
Yes, sir.
Definitely. Okay. Another thing is for you to visualize the normality, the characteristics must be a measurable characteristics. The characteristics must be a measurable characteristics. And another important thing, if you want your data collected from a process to demonstrate normality, then your process must be what? Very, very important point. What is that I've typed?
Standardized.
Standardized
Your
process.
process must be a standardized one. If the process is standardized and if your people are following it, then your process data will demonstrate normality, a bell pattern, a kind of inverted bell. This is called, distribution. Understanding how your data is distributed is, very important. And what we see here is, the distribution of the data. Okay. And the distribution can be called as normal distribution if you visualize a bell pattern. If you visualize a bell pattern. Okay. And see here, if any of these conditions are not fulfilled, let's say your sample is not large, what will happen? Normality might get disturbed, yes or no?
Yes, sir.
Yes, sir.
And measurement, your people don't measure correctly. Then also there is a possibility they're biased. Everything they are putting on the right side only.
Yes.
Then what will happen? The bell curve will become skewed to one side, right? So measurement issue can also disturb normality. And standardized procedures are available, but if your people don't follow, there are few people who do not cooperate and they don't adhere to the procedures, then also normality will get disturbed. Are you with me?
Yes.
Then also normality will get disturbed. Good. And then the properties of normal distribution. Properties of normal distribution. First property is symmetric about the central value. You know what will be there at the central value? The mean.
Mean value.
First property. Your data is expected to be symmetrical about the center. What does it mean? If I draw a line here, you see exactly the shape and the frequency on the right side as well as the left side. Do you see symmetrical symmetricity?
Yes, yes.
This
Yes,
will
sir.
happen. This will happen, if your data is normal. This will happen if your data is normal. This is called, symmetric. And I'll give an example. Imagine you manufacture something. Right now, you are manufacturing a product, and the diameter is 5.5 centimeter. Average diameter is 5.5 centimeter. Average diameter is 5.5 centimeter. And you produced, 100 pieces. Now, approximately 50 pieces.
உனக்கு ஆன்லைன்ல போட்டுமா?
Approximately 50 pieces will have diameter 5.5 or above. 50 pieces you will see on the right side. Remaining 50 you will see on the left side. Logical? Yes or no? If your process average is 50, then half of your process data will be above 50 and half of your process value will be below 50. Clear? Do you understand, all of you? But sometimes if the, what do you call, if the symmetricity is disturbed, and we call our distribution, a skewed distribution. What is a skewed distribution? The symmetricity is lost. The distribution will be called skewed. The distribution will be called skewed when the symmetry is lost. Okay. Say, for example, I introduce some outliers. Outlier means what? A big value. A value away from the mean. I introduce an outlier on the right side. If I introduce an outlier on the right side, you know what will happen? The mean will get shifted to the right side. Do you understand?
Yes, sir.
The class average is 75 marks, but the 3 candidates scored out 100 out of 100. Now the revised class average will move right side. Though the class average is 75, now since 3-4 students got sent from, now the class average will be pushed towards right. It may become 80 or 85. So as the average is moved to the right side, what will happen? The distribution will become right skewed. The distribution will now become what? Right skewed. Similarly, there is a possibility average can move leftwards also. Yes or no? Average can move leftwards. Then the distribution will be called what? Left skewed. Whenever a skewness happens, please understand these conditions are violated. Am I right? If you notice skewness in your process data, will you be able to relate to any one of these? The root cause is either there are large samples, the number of samples, are not sufficient enough. So some skewness you are experiencing, or, the measurement, it's not a measured data, or no measurement, there are a lot of problem. Then there can be a skewness, or if the process standards are not, really followed, then also this can happen, right? And maybe one other reason I can add here. If there are outliers. If outliers present, that is why whenever outliers are seen, we need to take some action to remove the outlier. Hope all of you
Outlier
understand,
means a special.
right?
Sir, outliers means special causes. Sir.
Outlier means the observation is far away from the mean value. Far away from the mean value. And the chance of producing data far away from the mean value is less.
Yes.
And so it is not, what do you call, a normal event as far as your process is concerned. So it cannot be considered as a common thing, isn't it? So it should be considered as special. If the if you move away from the mean, the more you move away, and the events will slowly become what? Special event. They are no more common events. So the thumb rule to differentiate whether the observation is due to common cause or a special cause is, I'll tell you. See here, what is this? Mean value. Okay. And now you move away from, you are moving away from the mean. Now, I am writing 3 S. S refers to what?
Sigma.
Standard deviation. Yes,
Standard
refers
deviation.
to standard deviation.
Standard deviation.
When I move 3 standard deviation away from the mean, either on the right side or on the left side, I come to a point. These points are called control limits, upper control limits, lower control limits. 3 standard deviation from the mean. Right side it is upper control limit. Left side it is lower control limit. Now, if any observation is found outside the upper control, outside the control limit, either on the right side or left side, they must be called as outlier. First definition of outlier. What is this? An outlier is an observation found beyond the control limits. Are you with me, all of you? Outliers are...
Sir, one question. If like a very peculiar question is like considering 6 sigma, this is 3s on either side. So is this a 3 plus 3 6 standard deviation, or it will be 6s on either side for a 6 sigma?
Yeah. Wait. This is one reason. The approach is named as Six Sigma. Motorola, they have named this approach as Six Sigma approach because a process will always experience variation. You see here, this is the variation your process is experiencing, right? And the total variation can be estimated as 6s. Total variation can be estimated as what? 6s. 3s on the right side, 3s on the left side, which means any process will have a variation. And the estimated variation will be how much? 6 times standard deviation. So based on this is one principle behind the Six Sigma approach. The principle is any process will experience variation, and that variation can be quantified as 6 times standard deviation. This is one reason the approach is named as Six Sigma approach. But Six Sigma capability is different. And your query is about the capability, whether the capability is Six Sigma or not. When you want to talk about the capability, you have to bring in the customer requirement. So far, we are studying only the process. Yes or no? We are only talking about the process and the process data. But where is the customer requirement? If you bring in the customer requirement, then we can comment whether this process can meet the customer requirement or not. And that ability of a process to meet the customer requirement is known as process capability. The ability of a process to meet the customer requirement is known as what? Process capability. That capability can be defined in terms of sigma level. All of you, do you understand? The 3s and 3s what I wrote refers to what? The variation in the process. Whether the variation in the process is acceptable to the customer or not acceptable to the customer, we can comment only after knowing the customer requirement. Yes or no?
Yes, sir.
Yes, sir.
Yeah. Now let me show customer requirement. Now the mean value here is 5.5, right? Now customer is telling this 5.5 plus or minus 1. 5.5 plus or minus 1. Now what is the customer requirement? Customer target is how much? Customer target is how much? 5.5.
Yeah.
Okay. Let me say it is no centimeter or something. 5.5 centimeters is the customer requirement. Let's say the thickness must be 5.5 centimeter. So what is the tolerance customer has given you? Plus or minus
That's 1.
1 centimeter. Very liberal tolerance. No customer will be giving this much. Now what you need to know is what is the maximum tolerable limit?
6.5,
6.5.
6.5. And the minimum tolerable limit is
4.5.
4.5. Now you have to what do you call? Now you have to compare your process with respect to the customer requirement. Now I'm going to see the bell curve. What you see here, this is your process. How is your process performing? Your process is performing from 4.75 to
6.25.
6.25.
6.25. But where is your customer requirement? Your customer requirement is 6.5, right? So now let me use different color for customer requirement. I'm bringing blue color. I'm bringing blue color. What is this? 6.5. And what is this? How much it is? 4.5, right?
Yes.
And what is the customer target?
5.5.
5.5.
5. So customer target is known. This is target. 5.5 is target. And this is upper specification limit. And this is lower specification limit. Are you with me, all of you? Customer requirement is visualized. Your process is also visualized. Now you have to check whether this process can meet the customer requirement or not. All of you, please tell me, can this process meet the customer requirement or not?
Yes, sir.
Yes, it will.
It can
Yes.
meet because the almost complete variation produced by your
specification.
process is acceptable by the customer, isn't it? Because customer already told you 5.5 plus or minus 1. The complete variation is acceptable. That means this process is capable process. It's a capable process. Are you with me, all of you? The meaning of capability?
Yes, sir.
If I run my process will produce, my process will experience variation. And the variation can be quantified using a formula what? 6 sigma. When you use this formula of 6 sigma, 99.73% of the variation is accounted. This is a what percentage? 99.73% of the variations will get accounted if you use this formula 6 sigma. So what is the risk you are taking? The risk you are taking is only 0.27 you have not understood, isn't it? 99.73% of the variation you have quantified. All right, done. So this process is capable. Now I'm going to erase all of these things. Now I'm bringing another customer. He is okay to pay any amount that you ask, but he wants a very tight tolerance. He wants a very tight tolerance. Look at this customer. What is his requirement? 5.5 plus or minus 0.25. In this case, the target is 5.5. What is the upper specification limit?
5.75.
5.75. And the lower specification limit is going to be 5.25. Now this customer want to place an order. Are you in a position to accept the order?
No, sir.
No.
If you have to supply 1,000 parts every day, even though he is ready to pay, the more rate per piece, you will still be, under loss only. Yes or no? Even though he is paying, more rate per piece, your rejections will be very high. Am I right?
Yes, sir.
See here, your 5.25 is here and 5. Okay, yeah, maybe somewhere here. So only in this region, you are able to meet the customer requirement. But how about here? All of them are rejections, isn't it?
Yes, sir.
This is cost of poor quality. So now you should also gradually develop skills to tell exactly what percentage of the parts produced will get rejected by the customer and what percentage of the parts will get accepted by the customer. If you could learn this concept, little more to the extent of what? Finding out what is the percentage of parts that will meet the customer requirement and what is the percentage of parts that will fail to meet the customer requirement. If let us say 90% of the parts are meeting the customer requirement, that means FPY is how much? If 90% of the parts can meet the customer requirement, first pass yield will be how much? 90%. If first pass yield is 90%, then remaining 10% is rejection.
Cost of poor quality.
Rejection leads to rework, and rework might lead to scrapping also sometimes. So the cost of poor quality. So what we want is we want a higher first pass yield. We want a very high first pass yield. We need, in fact, a first pass yield closer to 100%. So now I'm going to draw another thing. Listen to me very carefully. I'm drawing the specification limits here. Can you see upper spec and lower spec where I have drawn? I have
Yes,
drawn
sir.
the upper spec and lower spec exactly on upper control limit and lower control limit. Yes or no? I have drawn the specification limit exactly on control limit. That means the spread will be how much? 6 times standard deviation. What is there at the center? The mean is at the center. Okay. Now you have to tell me, is this process capable?
No, sir.
Marginally possible.
Yes.
It is like,
No, sir.
it is like your salary and monthly expenditure. Your salary is 1 lakh and your EMI and your other expenses, everything put together is also 1 lakh. Now, what is the situation? Is
High
it
days.
can I most of the time the situation is like this only, isn't it? So whatever we earn and almost equal amount we spend also, and this is called a just capable scenario. You just made it, isn't it? If somebody asks you, are you capable? Yes, theoretically you are capable. Yes or no?
Yes, sir.
But practically, the problems, what the problems you experience, only you will know. Right? And now this is a just capable scenario. When the process is like this, the capability is called the process capability. Please note. The capability in this condition is called 3 sigma capability. What is this process capability? 3 sigma capability. I think Prateek Mitra, you only asked the question, right? What is this process called? This is a 3
Yes, sir.
sigma process. This is a 3 sigma process. A 3 sigma process means it is just capable. Just capable. Right? But it's not really safe. Factor of safety is just 1, isn't it? What is the point? Why earning 2 lakhs and then spending all 2 lakhs same month? What is the saving? Where is the safety? If even some extra few thousand rupees, then you have to borrow from others. That is the situation. So this is called 3 sigma capability. Are you with me, all of you? Do you understand what is the 3 sigma process?
Yes, sir.
So once
Sir,
again,
why we called as 3 sigma process, not 6 sigma?
Yeah, because if you look at the center and the right side, from the center up to the 3 sigma, up to the upper spec, how much distance you have? 3 standard deviation. Similarly, here also 3 standard deviation. See, for standard deviation, sometimes, for samples, we use the symbol S. For population, we use the symbol sigma. Okay. So since there is 3 standard deviation on the right, 3 standard deviation on the left, or otherwise the distance between the specification limit and the process center. Distance between the specification limit and the process center is Distance is how much? 3 sigma. And so the
3 sigma.
process is called
3
3 sigma
sigma.
process.
If it is instead of 3, 4 is there, then we can't 4 sigma.
Very good. Correct. You have to
Yes.
bring 6 sigma here.
Yes.
Tell me, if you have to bring 6 sigma here, there are two options. One is you can push the upper spec outwards, isn't it?
Yes.
Do you think your
Yes, sir.
customer will allow you?
No.
No. This is ruled out. Now the only
Yes.
possibility is
Control plan shifting.
you can pull your control limit inwards. Yes or no? That is possible.
Okay.
Yes, sir.
You can pull your control limits inwards. How can you pull your control limits inwards? You can improve your process. Am I right?
Yes. Okay.
By
Sir,
improving your process, you see here your process is already standardized. According to the standard, this will definitely produce this much variation. But your situation is you want to reduce this variation to this much.
sir, sorry to interrupt. Why this process is called as a 3 sigma process? Unable to understand your explanation. Could you able to repeat one more time, sir, please?
Yeah, sure. No problem. You forget about this example. See, imagine you have a parking area, right? What is this parking? What are the 2 lines I drawn? The what do you call the parking area's side wall. There is a side wall on the right side. There is a side wall on the left side. This is what we call it as the upper spec and lower spec. Okay. The side
Okay,
walls
sir.
in the parking area represent the customer specification limit. Now, this is your process. Imagine your process as a car. Imagine your process as a car. Now you have to park your car inside this parking area. Now please tell me, will you be able to bring this car and park it inside this parking area?
Comfortably.
Yes.
Possible. Looks possible, but you have to be very focused. Isn't it? Because it almost occupies the whole area of the parking, isn't it? Okay. So now you have to exactly park your car at the center. Am I right? If you bring the center of the car exactly at the center of the parking area, then see, any process will, I already told you, how much is standard deviation it will experience? 6 standard deviation, isn't it? Out of that 6, the 3 standard deviation will be on the right side, 3 standard deviation will be on the left side. Are you getting my point?
This is by default, sir.
Any process will experience a variation, and that variation is, can be estimated using the formula 6 times standard deviation. So, and since the process is centered properly, you will have 3 standard deviation on the right side, 3 standard deviation on the left side. Now your car is fully occupying the parking area, which is not a good scenario. Yes or no? How will you get down from your car? You do not have any additional tolerance available, isn't it? So, the point is we are trying to understand how much tolerance our process is consuming. Who give the tolerance? Customer. You see, customer has given this much tolerance, yes or no? Customer has given this much tolerance. And how much tolerance our process has consumed? Tell me. 100% of the
100%.
tolerance, is consumed, isn't it?
Yes, sir.
Is it a good habit? Definitely no. Imagine, you give, a pocket money of 100 rupees to your children, and they spend the 100 rupees on the same day. They do not develop, the habit of saving, a certain percentage of it, right? And this kind of, capability is called 3 sigma capability. This capability is called what? 3 sigma capability. Now imagine this is a parking area. Now I purchased a small car. Now how many car I parked? In the same parking area, how many cars I have parked?
2.
2 cars. My car is half the size of the parking area. Now, parking this smaller car in a bigger parking area is a very convenient process, isn't it?
Yes, sir.
What is the variation my process will be experiencing? 6 sigma, isn't it? Am I correct? But even after my process, full variation is, visualized, I still have a tolerance. Can you see here?
Sir, why are
And
we
again,
calling 6 sigma here, sir?
see, any process will have a variation. And that variation, the statistical formula for calculating the variation is 6S. You know how to calculate standard deviation, right? You know how to calculate standard deviation. And
Yes, sir.
see, this is, an experimentally found observation. You all have to understand and then you have to use it, right? So when you have a bell curve, and the bell curve will never touch the x-axis. You see, it will keep on going like this. Similarly, it will keep on going like this. If I draw a line at the center, then there is 50% on the right, 50% on the left. Yes or no? Tell me, 50% on the right,
Yes,
50% on
sir.
the left. Yes or no? It is
Yes,
Yes,
yes.
sir.
sir.
Yes.
That means
Yes,
the
sir.
total area is, that means the total is 100%. Now, what I want is, I don't want to go up to infinity, which is impossible. I cannot go up to minus infinity, which is impossible. So I'll go only up to certain distance. I have come up to this. I just name this point, upper control limit and lower control limit. Now, I'm trying to understand what percentage of the area is now covered. And statisticians, they have found that 99.73% of the area under the curve can be explained if you study up to
3 standard. 3
3
standard.
standard deviation. That's all. If you study a process up to 3 standard deviation on the right and 3 standard deviation on the left, and we also call this point as what? Upper control limit and lower control limit. 99.73% of the variation is understood. Are you with me, all of you? What percentage? 99.73% of the variation is understood. If you study up to what? 3 standard deviation from the mean on right as well as left. Now, this is, an experimental study, and you can easily see this, property happening, whenever your data is normally distributed. So based on this understanding only, we also judge the capability of the process, right? So if the customer specification limits are here, LSL, and this is USL, and your process is only consuming this much tolerance. But how much tolerance customer gave? Very long, isn't it? Now, if I ask you, is this process capable? Yes or no?
Yes.
Definitely
Yes,
an yes. That means it has consumed only a portion of the tolerance given by the customer, not completely, isn't it? So if the process consumes, the entire tolerance, the situation will lead to just capable scenario, the 3 sigma. So we will come to this, one more time, but right now, try to understand the properties of a normal distribution. Okay. So now, when you consider the full variation, what is the percentage of the variation we are able to account? 99.73, isn't it? That means, what is the formula we used? 6 times standard deviation. Yes or no, all of you?
Yes, sir.
Yes, sir.
Now let us take only 2 standard deviation. 2 standard deviation on the right, 2 standard deviation on the left. Now we will be able to understand only 95.45% of the variation. We will be able to understand what percentage of the variation? 95.45% of the variation. If I consider only, and here for 95.45, The thing is plus or minus 2 standard deviation. 6 sigma means plus or minus 3 standard deviation, right? And now I am considering only plus or minus 1 standard deviation. Here, what percentage of the variation you have understood? Only 68.27. I want all of you to remember these percentages. 68.27, 95.45, and the other one is 99.73. And for 68.27, how many standard deviations are accounted? Plus or minus 1 standard deviation. And for 95.45, it is plus or minus 2 standard deviation. And for 99.73, it is plus or minus 3 standard deviation. Are you with me on this? This is another important property of normal distribution. Another important property of normal distribution. So now I will be asking, a simple question. What percentage of the variation can be understood if I consider plus or minus 3 standard deviation?
99.73.
99.73. What percentage of the variation can be understood if I consider plus or minus 2 standard deviation?
95.45.
What percentage of the variation can be understood if I consider plus or minus 1 standard deviation?
68.27.
So I can choose any number of standard deviation. Please understand. If I ask this question, plus or minus 1.5 standard deviation, what will be your answer? Tell me, all of you. If I go for plus or minus 1.5 standard deviation, what percentage of the variation is understood?
It is between 68 and 95.
68 and 95.
I like this answer, definitely. So you understood the concept. It will be between 68 and 95. Some value, maybe some 78 or 85 or something. Clear, all of you? See, you can I will also give few more terminology. So the plus or minus 3 standard deviation, when I take plus or minus 3 standard deviation, then this point is called what? Upper control limit. This point will be called lower control limit. Are you with me? Control limits are nothing but the points at a distance of 3 standard deviation from the center, and at the center the mean will be there. Okay?
Okay.
All of you, are you learning statistics here? It's not difficult, at the same time it is not easy.
Yes, sir.
Right? It is somewhere in between. Right? Okay. Now, if I consider plus or minus 2 standard deviation, I don't want to go up to 3 standard deviation. I want to go only up to plus or minus 2 standard deviation. Then this point is called warning limit, upper warning limit, lower warning limit. You understand? It's a different. It's not your control limit. It's now called warning limit. Warning limits will help you to understand 95.45% of the variation. What are these points called? Upper warning limit,
Lower warning limit.
lower. Now it is in your it is your decision to understand, to decide whether you want to understand the variation up to the control limit or up to the warning limit, or you want to study the variation only for a smaller limit, plus or minus 1 standard deviation. See, if your customer keeps the the specification limit very wider, right? Then you don't have to worry about your process variation. Am I right? Because your customer gave a very liberal tolerance. Yes or no?
Yes, sir.
Now you don't have to worry about the variation. But as the customer brings the specification limits, closer and closer to the target, there comes a requirement for you to develop a process with minimal variation. Are you getting my point? Develop a process with minimal variation. Let's say you develop the process with very minimal variation, a small process. Now you all tell me what will be the variation this particular process will be experiencing. What will be the variation this process? This is no highly standardized. You see here.
68.2.
68.
Come again, 6? See,
68.2.
wait.
Sigma.
Here
High
also the
confidence.
formula is 6 times standard deviation only. You have to calculate the standard deviation for this process and then multiply by 6. Yes or no? Let's say for this process, the standard deviation is S1. And so for this process, standard deviation may be what? S2. And the formula will be 6 into S2. See, for any process, I draw 3 processes here. A wider, a moderate, a narrower. And this process, the standard deviation is S1. This process, the standard deviation is S2. And this process, standard deviation is S3. Now tell me, which process has less variation? P1 or 1 or 2 or 3? S3 has less variation. But S1 has more variation. Now I want you to quantify the variation. No, see, variation has to be explained in some manner. So this process, the first one, the variation is quantified in using this formula, 6 into S1. Here, what is the variation, total variation? 6 into S2. Here, what is the total variation? 6 into S3. The total variation wise, the third one is better. But if you look at the formula, in all the 3 cases, what is the formula we used? Standard deviation multiplied by 6. Are you with me, all of you? Yeah. In all, whenever you use 6, 99.73% of the variation is accounted. We have not accounted this. Please note. Beyond the control limit, we don't know what will happen. But up to the control limit, what will happen, we have understood. Are you getting my point?
Yes.
Yes. Okay. Now we can apply this logic, to any scenario. Imagine when all of you, when you are going to the office, let's say the office time is 9 o'clock sharp. But some allowance is given. And now what we do, all of us will try to reach at 9 o'clock, but at the same time, we may take extra 1 or 2 minutes, yes or no?
Yes.
9 o'clock plus or minus some, let's say 30 seconds or 40 seconds or 50 seconds, some value. Let us say I'm saying 9 o'clock plus or minus 3 seconds. Sorry, 3 minutes. 9 o'clock plus or minus 3 minutes. If you actually, look at your 100 days of, reporting time to the office, since your office is, really allowing, the plus or minus 5 minutes, your office is allowing. And your actual reporting time is also found between what? 8:57 and 9:03. Are you getting my point? 100 days of data when you check, you are reaching the office always between what? 8:57 and 9:03. All right? And now the 100 days data is available. Now you separate, no? 9 plus or minus 1 minute, how many days? 9 plus or minus 2 minutes, how many days? 9 plus or minus 3 minutes, how many days? 9 plus or minus 3 minutes, when you consider this, majority of your days will, fall inside. Yes or no? But when I reduce it, only a certain percentage of the data may not fit in this interval. Another percentage may not fit in this interval. That means, again, the same rule. And statistically, it is found that 68.27% of the data you will be able to fit inside your 1 sigma limit. 95.45% of the data you will be able to fit inside 2 sigma limit. 99.73% of the data you will be able to fit inside 3 sigma limit. But I already told you, for all these properties to get, demonstrated, you should understand, you should maintain this. Your process must be standardized. Your people must, respect the standard. And then there are no measurement error. You are very good at, taking samples, and no, there are no disturbances to the process. If there are no disturbances to the process, outliers will not be present. If these conditions are maintained, you can always verify the properties of the normal distribution. How many properties we studied? A bell curve is symmetrical about the center, yes or no? A bell curve
Yes, sir.
is symmetrical about the center. And what is there at the center?
Mean.
Mean process average, mean value. Very good. And 68.27% of the observations can be found inside plus or minus 1 sigma limit. This is another property. Do you agree? Do you understand, all of you?
Yes, sir.
Yes.
And 95.45% of your data points or observations can be found inside warning limit. Warning limits are nothing but plus or minus 2 standard deviation.
Yes, sir.
99.73% of the observations can be found inside control limits. Control limits are can be calculated using plus or minus 3 standard deviation. X bar plus 3 standard deviation will take you to what? Upper control limit. X bar minus 3 standard deviation will take you to what?
Lower control limit.
Lower control limit. So please understand this. And also, if your data is normally distributed, then one other property you will be able to see. The mean will be equal to median and mode. What is this equation I am writing? Mean will be equal to median will be equal to mode. When this will happen? When your data is
Symmetrical.
perfectly normal. When your data is perfectly normal. And for a perfect normal, for your process to generate a perfect normal data, look at the requirement. A standardized procedure, a standard way of doing the work must exist, and all the people should follow. Then automatically the data will demonstrate what? Normality. You will be able to see a normal distribution. The visualization of data is called what? Distribution. And that distribution will be normal. That distribution will be bell curve. That distribution will be a Gaussian distribution. Because Carl Friedrich Gaussian, he is the one who found out this theory, right? You can call it normal distribution, you can call it bell curve, or you can call it Gaussian distribution. All of them are same. Okay. And these properties, you should be able to get it verified. If you are not able to verify, either there is problem with any one of this, or your process got deteriorated. If the normal distribution property is disturbed, that means there are special causes. That means there are special causes. What are special causes? Some influence. Some influence, is happening, and your process is failing because of the influence. So special causes should not be part of your data. And the definition of special cause is a value found beyond what? Control limit. If frequently values beyond control limit happens, then there is a problem, your process is experiencing a disturbance. And tell me, if the process is experiencing a disturbance, can it still continue to produce normal data? Will you perform normally if you are experiencing disturbance?
No.
No, sir.
So your intervention is required. Please understand, your process desperately needs your intervention. You have to study what is that disturbing your process. You should rectify it. Yes or no?
Yes, sir.
So statistics is helping us to understand whether our process is performing normal or not. If my process is performing normal and that is acceptable to the customer, then your process is capable. Please understand. What is that I'm telling? Your process is performing normal. Say, for example, you are attending the training program and you are preparing, very normal way, right? Because you have only, hardly you have 2 hours you can spend during weekend, 2 hours or 3 hours, and that much you are spending. and you are able to really, perform well in the exam. That means your process is normal. At the same time, your process is capable also, right? So, but sometimes what happen, I'll tell you, your process may be normal. Your process is normal, but your process is not capable. Possible or not?
Yes.
All the bell
Possible.
curve, all the properties, everything is satisfying. But customer gives a very tight tolerance. Do you understand? When
Yes.
customer gives a very
Yes.
tight tolerance, even though your process, you have a standard and everybody follows it, but finally, the requirement is not met. Now, what should you do in this situation?
We required to match his requirement with the
Very good.
standard.
This is called process improvement. Very simple.
Yes.
This is called what? Process improvement. Okay.
Yes.
And another scenario. Process is not normal, abnormal. Abnormal means there are outliers. But customer gave wider tolerance. Customer gave wider tolerance. Now, how will you react? How will you react to this scenario?
We can
Process
tweak
is abnormal, but still it remains capable. Tell me, will you ignore this, or would you like to pay some attention and correct the abnormality into normal?
We need to correct the abnormality to normal.
Correct. Very good. Very good. That's this, we normally don't do it. When actually, this happens in a workplace. Let me give an example. Your child has a habit of scoring between 80 plus or minus 5. What is normal for your child? Scoring 80 plus or minus 5. You see a variation limit of your child, yes or no?
Yes.
The spread 80 plus or minus 5 is the range your child normally maintains his score. But the pass mark is in the school, the pass mark is only 40. Pass mark is only 40. And now considering the pass mark and considering our the process nature, is our process capable or not? Capable.
Yes.
But suddenly in one examination, your child got 60% only. Still the situation is capable, yes or no?
Yes. Yes.
Yes.
But this is not normal. Please understand. This is not normal. Normally, we score, in that range, 80 plus or minus 5. But now the 60 is far away. It is below the lower control limit. Can you see, all of you? Now you have to talk to your child, isn't it? Yes or no?
Yes.
Yes, sir.
You should talk. You should find out what went wrong. Isn't it? What is the problem? Whether the particular, module of the lesson is tough or what exactly is the reason. So that has to be figured out. And if you take an action, the process will again get normalized. Yes or no?
Yes.
Are you able to relate normality with customer requirement? Please tell me, all of you. Normality is nothing but understanding the nature of a process, understanding the DNA of your process. If you set something at the DNA level, then your process will remain capable forever. Yes or no?
Yes.
Okay. So I want you to know up to this. As an introductory learning about statistics and normal distribution, we learned a lot. But we went beyond and then discussed about capability also, because there were few questions we discussed. But I want you to have a clarity on the topics, statistics. You all know what is statistics now?
Yes, sir.
Yeah. You all know what is descriptive statistics?
Yes.
Yes.
You all know what is inferential statistics?
Yes. Yes, sir.
Yes. And then you all know what is normal distribution?
Yes, sir.
Yes.
And you all know certain properties of normal distribution?
Yes, sir. Yes, sir.
Yes. But if we ask you what are those properties, the normal distribution is
Symmetry about
symmetrical
about
about
center
the
value.
center. What will be there at the center?
Mean.
Mean. And if the distribution is a perfect normal, then the another condition will get satisfied. Mean equal to median equal to
Mode.
if outliers are present, then this equation will get spoiled immediately.
It is skewed.
Yeah, it will be skewed. If you introduce an outlier on the right side, then it will be right skewed. If you introduce outlier on the left side, then it will be left skewed. Do you understand? We don't want any kind of skewness either on the right or on the left. We want a normal performance because normal performance is easy to demonstrate. All of you, yes or no?
Yes.
See, attending the class for 3 hours, is normal. Anybody can attend, isn't it? It's not a Guinness record, isn't it? But can we achieve something within that 3 hours? That is our capability. But no, so there is what do you call certain property of normal distribution. So the mean is at the center, and the total variation will be 6 times standard deviation, isn't it? Total deviation will be 6 times standard deviation, and normally if the curve is perfect symmetrical, then there is no skewness. But whenever skewness happens, you can understand there is an outlier. Then you need to check why the outlier is part of your process. What is that really produce this outlier, and you have to fix it so that your process will be brought back to normal. Is it good or not, all of you? Bringing your process back to a normal way of performance is good or not?
Good.
Good.
Definitely good. And that must happen. See, all of us have a certain nature. We always act according to our nature only. Yes or no? So similarly, your process should also perform according to his nature. And now we compare the nature of the process with the customer requirement. If the nature of the process and customer requirement you compare and you see the situation favorable, then you can accept the order, and then you can actually process it. You will not have any failures. You will not have any rejections. Cost of poor quality will be minimal. Most of the time we don't do this and see all the rejections only when we actually run the process. And nothing wrong if that happens, then we have to study and then re-engineer the process. Okay, this is called process improvement. I improve the process. After improvement, you have to again standardize it, because standardization will bring the consistency. Because the variation is the problem, yes or no? So through standardization we can control the variation. So we understood the bell curve or normal distribution. We also understood properties of normal distribution. We also understood the terminologies like control limit and warning limit. We understood the rule 68.27, 95.45 rules of probability, and then 99.73. So 99.73% of the variation can be accounted if we consider control limits. 95.45% of the variation can be accounted if we consider what?
Warning.
Warning limits. Warning limits are plus or minus 2 standard deviation. Okay, I think this much all of you have understood clearly, and we can break here.
Sir,
And then
one
as
doubt. Sir, earlier you were telling about calling 3 standard deviation in one scenario and the same as a 3 sigma in one scenario. Can you explain that?
yes
Because
and sigma, right?
yeah,
Yes
some
and
area we
sigma.
have to tell sigma, and some
Yes.
scenario we have to standard deviation. Can you brief that?
See, sigma is also a standard deviation. S is also a standard deviation. Sigma refers to population standard deviation. S
Okay.
refers to sample standard deviation. You just have to ask yourself, the data in your hand is sample or population?
Okay.
It is most of the time it is sample only. So it is yes only most of the time.
A standard deviation.
Standard deviation means yes only.
Okay.
But If you are very sure the data in your hand represents the population, then the standard deviation calculated from it is sigma.
Is there any thumb rule? Population means 100 and above, or sample means so much. Any
That
thumb
has
rule?
to be that has to be that has to be judged by the team and thoroughly considering the situation. Let us say you
Okay.
got an order to produce 1,000 parts. Now all 1,000 parts together is the population. And if you go for an 100% inspection, then only you will have the population data. If you do not go for 100% inspection, you only take some 3 samples every 1 hour. Then end of the day, you are left with sample only.
Sample.
So in such a case, it is sample standard deviation.
Okay.
But 100%, you see, when you go for 100% inspection, you rule out the requirement of all the statistics and everything, because you already studied the result, isn't it? You checked
Yes, sir.
all 100 pieces and you found everything is okay. Now, where is the question of rejection?
Okay. So
Right?
otherwise both
So
are equal. Meaning is equal. Both are. It's only
ultimately,
based on the population.
yeah, see, wherever 100% inspection is not possible, right? We are left with an option of sampling only.
Sampling.
But our idea is to understand the population always. See, we are not only interested in understanding the samples. By studying the samples, we actually want to understand what? Population.
Variation.
If you are very good at the judgment, judging the sampling technique, judging the sample size, if you are very good in all those things, your sample standard deviation will be very, very closer to population standard deviation. You have to use all your experience and adjust your what do you call samples gradually, and freeze on a sample collection plan where the sample standard deviation will be very, very closer to population standard deviation. That means whatever you see on the sample, same will be the experience to your customer
Understood.
also. If you are not good at sampling, deciding on the sample size, you do not know the nature of your process, then all your discussion with your customer will be only assumptions. You cannot guarantee anything.
This will happen only when the process is totally stable or capable. At that time, both
Very
will be
good,
matching.
very good, very good. You have to. That is why you have to stabilize your process. You stabilize, so the behavior of your process is understood by you. And
Thank you,
now
sir.
the behavior is understood. Now other side you are bringing the customer requirement. Whether this behavior of my process and the requirement of the customer, is there a match or not? You will be able to understand percentage match and percentage failure.
Okay.
The percentage match is nothing but first pass yield. The failure is the rejection. So the knowledge of normal distribution finally leads to percentage of success and percentage of failure. Through the sampling study, you are just understanding the percentage of success and percentage of failure. If percentage of failure is too high, process improvement is required. If percentage of success is too high, it's better to leave the process as it is, because already it is doing extremely well. First pass yield is close to 100%. Leave it as it is, right? And though and even though the first pass yield is very high, you can still check one more thing. What you can check is okay. Let me share. So yes, see here, my upper spec is here, lower spec is here, but my upper control limit is here, my lower control limit is here. Now percentage success is very high, yes or no?
Yes, sir.
Percentage success is very high, percentage failure is very, very low, because it has got an additional tolerance. You see, this tolerance is not consumed.
Buffer.
Even if something goes wrong, an outlier falls, the outlier will still be falling here only.
Yeah.
Even outlier also cannot lead to customer dissatisfaction. But whenever an outlier happens, you have to alert yourself and improve your process, so that the outlier cannot go to the level of the customer. If you don't react here, then next outlier can hit the customer satisfaction. And now another gentleman, he want to improve this process like this. Look at his thinking. The process is already doing extremely well, and
We want to
he
narrow
will
down.
further, make the process more and more stable and more capable. When I say here the success rate is, let us say 99%, here it is 99.9%.
9%. Correct.
A Six Sigma process will guarantee this much percentage of success. 99.999%. Almost a zero defect scenario. If at all there are any defects, it will be limited to what? Definitely below 3.4 DPM, defects per million opportunities. I hope you are, all of you are able to relate the concept of, statistics and normal distribution to like process capability, rejections, yield, isn't it? We should be able to see. You can just stand next to the process and ensure zero defect scenario. But can you stand always? Not possible. So you ensure the nature of the process itself is to produce what?
Good part.
Zero defect scenario.
Zero
That's all.
defect.
The process by nature will not do any mistake. All of you ask yourself, have you tuned your nature to avoid mistakes and failures?
Repeat, sir.
So we have to tune ourselves in a way that, we never, get into a kind of, mistakes and failures. Our intentions are very clear. We want to be, free from mistakes, free from errors, and we don't want to get into any troubles. So that should be, the kind of, what to say, the behavior we must develop. The same thing, is applicable to the process also. Yes or no?
Yes, sir.
See, we cannot inspect, somebody, always to check whether you're doing right or wrong. Then what we need to do is we just have to change his nature. Let his nature itself be, very correct. If someone is, naturally correct, then he doesn't require what?
Policing.
Somebody to supervise, isn't it? Yeah, policing is not required. So he will do always correct, on his own. The same way, our process also. Our process, shouldn't require 100% inspection, 100% rework and all those things. A process on its own should be, should produce higher first pass yield. That is the point. Okay, so let us have a short break here and then we can continue after the break. Okay, short 15 minutes break here. Done?
Yes, sir. Thank you.
Yeah. Maybe some of you can come on camera and stay on the camera so that we can continue with the rest of the topic. So the MSA refers to what? Measurement system analysis. MSA refers to measurement system analysis. What is this measurement system analysis and why should we do this? The moment you have a doubt about the data that is produced to you, any report somebody is submitting and you are doubting it. Say for example, they report, a higher capability. One of your supplier, they report, sir, we are operating, our first pass yield is 99%, or our first pass yield is 100%, our PPM is 0, but you are doubting it. In such a case, definitely you can conduct an MSA. And based on the MSA, you can validate whether the report submitted to you is accurate or not. Are you with me, all of you? The purpose of MSA? Or within your factory also, within your workplace also. The moment, you are doubtful about the information that is presented to you, then you can conduct an MSA and understand how good is the data. used in that, analysis and preparation of the data, preparation of the report. If the data itself is contaminated with error, then all the reports will also be contaminated and then it will be misleading. All of you agree with me on this statement? If the data is contaminated with error, all the statistics you calculate, all the capability, index you calculate, or anything that you calculate, interval you calculate, whatever you do, using your statistical knowledge, the purpose of statistics is to make the right decision. But if there are manipulations and if your data is, highly biased, error contamination, then your decision can become misleading. If you want to avoid misleading decisions, want your decisions to be accurate and correct, then it's a good idea to perform a study known as measurement system analysis. Are you with me, all of you?
Yes, sir.
Yes, sir.
Yeah, because it's a data-driven exercise, data-driven project. We rely heavily on data, and data quality is very important. Data purity is very important. Just like, while driving a car, your windshield must be very clean. If windshield is not clean, if there are a lot of contamination, then what will happen? You can't see the road clearly, isn't it? If you can't see the road clearly, then how can you drive confidently? Yes or no? The same logic. If the data used in your analysis is not really clean, it is biased, then it will lead to misleading conclusion. And so, about institution known as AIAG, Automotive Industry Action Group. It's a consortium of industries like, your Ford, Chrysler, and many automotive industries. They have developed a guideline. According to the guideline, the permissible error in the data should be less than or equal to 10% of the tolerance provided by the customer. What is the guideline? The error, measurement error, if at all measurement error is committed, to what extent it is permissible? 10% of the tolerance provided by the customer. I'll give an example. You are developing, you are producing a product, and the diameter of the product must be 100 plus or minus 0.5. 100 plus or minus 0.5. Right? Now, what is the upper spec? 100.5. What is the lower spec? 99.5.
99.5.
So, what is the total tolerance?
1 mm.
0.5 on the right side, 0.5 on the left side. The total is 1 mm.
1 mm.
Now, this is the tolerance provided by the customer. What is 10% of the tolerance?
0.1.
0.1.
So, if we use a measuring instrument
Please
and
count.
collect a data, the maximum permissible error in your data should be 0.1 mm, not more than that. Are you with me? Accordingly, you have to select the instrument. Right? If your instrument is capable of measuring accurately and limiting the error to below 0.1 mm, then it will pass through the AAG guideline. Are you with me, all of you? Yes.
Yes,
The
sir.
error is nothing but the deviation from the true value. The error is nothing but what? The deviation from the true value. There is a special name given to it. The deviation from the true value is also called as bias. It is also called as what? Bias. BIAS. What is the permissible bias? Below 10%. But bringing the bias below 10% requires, a discipline while using a measuring instrument and collecting data. Am I right? Can you all tell me what are the disciplines we should learn and then maintain to ensure the measurement error is limited to 10% of the tolerance provided by the customer? Clear, all of you? The context of MSA?
Yes, sir.
Yes.
Yeah, tell me what are the discipline we should maintain to ensure the error is under control. 10% is okay for me because there is
One discipline is selecting the least count of the instrument
Very good.
is 10% of the tolerance. That is one way.
Excellent point. Excellent point. If the tolerance is given, the least count should at least be, 10% of the range of the tolerance. For the same example, the error required is 0.1. So the least count should necessarily be 0.1, isn't it? So if the least count is 0.5, the instrument is not suitable. If
Yes.
least count is 0.1, yes, instrument is suitable. Least count is 0.01, instrument is fantastic. So excellent point it is. Very well.
Correct.
Very good. Then what other thing?
Appraiser also to be qualified for that to check the instruments.
Very correct. The appraiser must be trained. The appraiser must be trained on how to use the measuring instrument and then how to actually collect the data. The process of measurement must be explained and the appraiser must be trained. That means a standard procedure must exist. Otherwise, appraiser to appraiser variation will populate. Yes or no? Variation finally becomes error in measurement. The same variation will finally become a defect in your product. Yes or no?
Yes, sir.
So, appraiser to control appraiser variation, you must train your people and you must standardize the procedure of data collection and make it a kind of what to say, a procedure, a foolproof procedure, so that whether you collect the data or I collect the data or someone else collect the data, we all will get the same reading. If all of us get the same reading, then our readings and measurement can be considered to be consistent. Do you all understand? Consistent. If you involve appraisers, maybe not two appraisers, three appraisers, or multiple appraisers, then what happens? Consistency comes into picture. Right? If you and me align together, follow the same procedure, produce the same reading, then we both are reproducible. Then we both are what? Reproducible. If we do not demonstrate reproducibility, it will finally get the shape of a bias. Yes or no? If we don't agree to each other while measuring the same thing, then definitely it will become part of the bias. Yes or no? Bias is the final error. Your final error will get influenced by a, a form of inconsistency called as reproducibility error. Whenever multiple appraisers are brought into picture, reproducibility has to be ensured. Clear, all of you?
Yes, sir.
And always in measurement, as a confirmation, we always measure the characteristics multiple times. We always measure the characteristics multiple times. Let's say you want me to measure the diameter, and you purposely want me to measure the same diameter two times, three times. Now, if I measure the same diameter two times, three times, all two times, three times, I should get the same reading. This is called repeatability. This is called my repeatability. But if I do not demonstrate 100% repeatability, whatever percentage of repeatability I lose can also become what? Part of the bias. Do you agree, all of you?
Yes, sir.
See, ultimately, we want to control the bias. We want to limit the bias to what is what level? 10% of the tolerance. So, in order to reduce the bias, we are trying to control the inconsistency. Control the inconsistency. Okay. Some few other discipline we have to follow.
Environment.
Environment, yes. Environment. Yes, whenever you measure, the characteristics, also please define about the environmental condition. What should be the environmental condition at the time of data collection? You have to define. So that thereby the environmental effect is also taken into account. Most importantly,
Selecting parts also should be the same position we have to check because
Yes,
the
correct.
part will have the variation.
Very good. So part position, how do you hold it on your hand? How do you hold the instrument on your hand? Whether you hold it on a table, everything matters. No, there can be parallax error and all those things. The measuring instrument condition, is very important. We have to store the measuring instrument properly. We have to follow the usage instruction correctly. If you take care of all of these things, then you will be able to achieve one thing called consistency. What is it you are achieving? Consistency. Consistency in the measurement is very important because consistency is the basis for accuracy. All of you, do you understand the difference between consistency and accuracy?
Yeah.
What does consistency refer to? In one line, if you have to give me a definition, what is the definition you will give me?
Similarity in result.
Similarity
Quality.
In result or a process.
Yeah, here
Uh,
now we are talking about measurement. So we want a similarity
gen-
in measured value.
generating the same
Whatever,
value again and again.
very good. We want the readings, the measured readings to be closer to each other. If the readings are closer to each other, your readings are considered to be consistent. Are you with me, all of you? Now, consistency can be of two types. One is reproducibility, another one is repeatability. Reproducibility means consistency between multiple appraiser. That is reproducibility. But repeatability means the consistency within
Same
single
appraiser.
appraiser. If you can achieve consistency, then there is a greater chance you can also achieve accuracy. Are you with me, all of you? If you can achieve consistency, there is a greater chance you can achieve accuracy as well. But if you can't even achieve accuracy, then there is a big, risk involved in maintaining the or in achieving the accuracy. Are you with me, all of you? Do you understand this? There are two terminology. One is accuracy, another one is consistency. In my MSA, the consistency is otherwise called as precision. The consistency is otherwise called as precision. Precision, there are two types of precision. One is repeatability, other one is
Reproducible.
reproducibility. Same appraiser, same part, same instrument, same characteristics, multiple times. And the outcome expected is very closer results or the same results. If the results are same, then you can immediately, call it, good repeatability. Hope you all understand it. If multiple appraisers measure the same part using the same measuring instrument, using the same procedure,
Reproducible.
if they get the correct reading, the same readings, then it is called reproducibility. See, while talking and understanding the concept, I think, all of you are finding it easier. But demonstrating repeatability, demonstrating reproducibility is really, really a challenge. So I'm going to do a small live exercise right now, and I'm going to check the participants' ability to achieve the needed precision. Yes, come on. No questions? Okay. So I'm going to check, your the participants' ability to achieve the needed precision. Okay. That means I want all of you to be repeatable. I want all of you to be reproducible. For that, I want you to use a measuring instrument. All of you, do you have a stopwatch in your phone? Do you have a stopwatch in
Yes,
your
sir.
phone? Yeah.
Yes,
Please
sir.
open the stopwatch and please check whether, please first check the least count of it. Because all of us, when we are going to work together, we all must have, the same or similar instrument. So let us check. Go to the stopwatch and check the least count of it.
Millisecond.
Yeah. So What is the least count of the stopwatch? Yeah, I could see. What is the least count of the stopwatch all of you have in your hand? Please type the least count in your chat box. I will also type the least count of the stopwatch in my mobile phone. And all of us should have a same least count when we are working together and measure the same thing. Can least count be 0? Tell me, any of all of you. Can least count be 0? What is
0.
count? Where is the count if you say 0? It cannot be 0.
0 1
Least
second.
count
0 1 second.
0.01
second.
second. 0.01 second. Whomsoever typed 0.01 second, you are correct. So if you have typed something other than 0.01 second, there is a serious problem involving you in data collection. Yes or no? If we involve, people who do not even know what are they measuring and what is the data mean, then definitely see, after calculation, the small error, will be completely giving you a misleading, information. So you have to be very conscious during the data collection, consciously control the error, right? Good. So 0.01 second. And now maybe, some more participants can come on the screen and we're going to do a small exercise, right? So what will I do? I will play a song of your choice. I'll play a song of your choice, right? Do you have any preference? Uh, Tell me, all of you, any specific movie song, any specific, song you can tell me. I will play. And all of you as a team, you have to measure the duration for which I am going to play the song. That is a very simple task. While enjoying the song, you should also be carefully measuring its duration. That is a task. Is it manageable, all of you? You can enjoy the song, you can
Yes,
also sing along, you can also dance along. I have no problem. You can do all of that you want. But finally, you should also be able to give me the correct reading. The reading is simple, duration of the song. You all know what is mean by duration, isn't it? The time
Yes, sir.
from start till
Stop.
end of the song. Yeah, stop. So when I play the song, you hear the sound. That's a start point. Similarly, when I stop, and you will not be able to hear the song. So the start point and stop point is defined. This is called operational definition. All of you, are you comfortable with the operational definition or any confusion here?
Clear.
If there is a confusion here, then definitely there will be too much error. So we must avoid the confusion here. So that is the purpose of operational definition. If you are doing project, in your project, whatever characteristics you want to measure, you want to you utilize, use it in your analysis, you must include a definition. Very, very important. You must include a definition, right? That is called operational definition. So now I will share the screen and then I'll play the song. So all of you, please be ready to enjoy the song, at the same time measure the duration of it. And after the measurement, you can post your reading in the chat box. You can post your reading in the chat box, but the reading must only be in seconds, right? The reading must only be in seconds. So minutes and milliseconds, centiseconds, nothing is allowed. No minutes, no hours, everything should be in seconds. Is this rule clear? Operation definition clear?
Yes.
Right. But see, you see, and what is expected is a higher level of consistency. Okay, we don't have to watch, the video from my channel. It will be boring. So tell me the song that you like. Famous song, Hindi or Tamil or English? Okay. I think, what is that one? Hindi. Shahrukh Khan. Shahrukh Khan, right? What is that movie?
Latest movie, Jawan.
Javana?
That's one of
You
the
tell
movie.
me. You tell me. Okay,
Yeah,
Jawan.
Jawan.
Okay.
Yes.
So before that, I will stop the recording because everything will get recorded otherwise. So we're not supposed to. 1 minute. Recording pause. Please remind me after this, we'll resume the recording. So it has come.
No.
Come on, this one, right? Hmm. I think it's a good song selection, right? Okay. Wait. I will anyway replay. Okay, are you ready, all of you? Please reset your stopwatch. I
Yes,
hope
sir.
the audio is coming, right? Sound, no problem.
Yes,
Is
yes.
audio? Very good. So reset your watch, stopwatch, set it to 0. And as soon as I hit the play button, you can also hit the start button, right? And
Yes,
then
sir.
anytime I may close the complete thing and you have to stop your watch and then post the reading in the chat box. And importantly, the reading must be in seconds.
Seconds.
Shall we hear this song? Ready, all of you?
Yes.
Yes, sir.
Okay, so 3, 2, 1, and here we go.
Not playing.
So not playing. We don't hear anything.
1 minute. Oh, sorry. No issues. You can reset. We'll play again. Share the sound. Are you seeing the screen?
Yes.
Yet to come.
Okay.
Yet to come.
Okay.
Sir, I think we are still recording.
What happened?
I think we are still recording it.
Oh, is it?
No, we have to reset.
No, recording. Oh, recording is on. Record. Yeah. Type the reading. Type the reading in the chat box. Reading should necessarily be in seconds only. If it has gone for more than a minute, then you should convert everything into seconds. Very good. All of you are typing it the right way, but I need the 2 decimals. You are not supposed to round off and 64, 65. No, it should be 65.76 that way. Very good. So all of you have understood the definition and you measured it. Great. Now, looking at the chat box, are you seeing a variation in the data? Are you seeing a variation in the data?
Yes.
Yes, sir.
Yes.
But there is no variation in the video. Video is single video only played, isn't it? But you all measured and produced different readings. There is a variation. This variation is a form of inconsistency. This is what is called as reproducibility error. Am I correct, all of you?
Yes, sir.
There are so many appraisers, so many data collectors involved. In fact, all of you are data collectors now. But there is a problem in getting the right required agreement level. All of us didn't agree to each other. Though the difference is small, but still there is an inconsistency. This form of inconsistency is known as what? Reproducibility error. Now, if the reproducibility is smaller, error is smaller, you look at the what do you call the chat box and find out whether the error is smaller or problematic. If it is too small and not going to really affect your decisions, not going to really, give a misleading reports, then it is not an issue. I think your readings are acceptable. Yes or no? Of course, this also depends on the amount of tolerance, you are expected to work. Am
Yes,
I
sir.
right?
Yes, sir.
If the customer gives a very small tolerance, then it will be a challenging scenario. Then you may have to even control, the variation what we are, witnessing right now. So what is this form of inconsistency called? What we experience right now? What is this called?
Reproducibility.
Reproducibility.
Reproducibility error.
It is actually the reproducibility error. Now just imagine if I play the song for one more time, for the same duration, how many of you are confident that you will give me the same reading? No? Like first time you gave me a reading. Are you confident that you will give me the same reading when I play it one more time for the same duration?
No, sir.
No, no, sir.
That is
No.
also difficult. That means there is going to be a kind of disagreement within your reading. There is going to be a kind of inconsistency in the readings produced by the same appraiser. This form of inconsistency demonstrated by a single appraiser is known as what? Repeatability error. Are you with me, all of you?
Repeatability.
See,
Okay.
I want all of you to understand the various form of errors that can accumulate in your data. If your people are not conscious, not really aware of all these possibilities, then they may actually commit all these error, and then your data might be might become a clutter. Your data might become uh, unreliable for any analysis. Now the repeatability error and reproducibility error together collectively called as precision error. Are you with me, all of you? What is precision error? It refers to both repeatability error and reproducibility.
Reproducibility.
Refers to both repeatability error and reproducibility error. So I will type that as well in the chat box. That means precision error refers to both repeatability error and reproducibility error. Very simple.
Should we say any one will be a precision, or it's a combination of that one? If we have both, then only we can say precision, or
No.
we can. Okay.
See, if you involve multiple appraiser,
Okay.
definitely reproducibility error will populate.
Yes, sir. Yes, sir.
If you involve only one appraiser, then there is no chance of reproducibility error. Right?
Repeatability error will come.
Only
Yes.
repeatability error will be there, right?
Yes, sir. Yes, sir.
You just have to understand the scenario, right? Whether you involve only one person for data collection or multiple person for data collection. If it is multiple, then you will have two forms of inconsistency, both repeatability error as well as reproducibility error.
Reproducibility, yes.
And there are formulas available in statistics. Like I told you, 6 sigma is the formula to quantify the variation. Similar way, we can even quantify the measurement error. So right now, don't worry about it. The conceptually, it is understood.
Okay.
Now I have given a definition in the chat box. Precision error is equal to sum of repeatability error and reproducibility error.
Okay. Okay. Got
What
it.
is repeatability error?
Sum
Quantify.
of, yes.
What is reproducibility error? You quantify. And then you add them together.
Okay.
The outcome, the output is known as precision error.
Okay. Got it.
Now I want you to compare this precision error against the tolerance provided by the customer. Are you with me, all of you? Compare the precision error against what? The tolerance. Keep the denominator as tolerance. What is tolerance? What is tolerance?
Boundary condition.
Very
Upper
good.
and lower. Upper and lower.
Very good. The upper specification limit minus lower specification limit. That is the tolerance.
Yes.
You simply find out the difference between upper spec and lower spec given by the customer. Now you know the tolerance. Oh, this much tolerance, my customer gave. This much tolerance. Now, what is the precision error? You find out a ratio. Are you with me, all of you? You are getting it. Repeatability error, quantified. Reproducibility error, quantified. Whenever you want to quantify, error is nothing but variation in the data, isn't it? Total variation is equal to total error. So, the repeatability error, the formula is 6 times standard deviation. Reproducibility error, 6 times standard deviation. So, don't worry about the formula right now, but there is a way out. So repeatability is calculated, reproducibility is calculated, and it is summed together. Now it becomes the precision error. The precision error is compared against what? Tolerance provided by the customer, which is USL minus LSL. Now this ratio is known as P by T ratio. This ratio is known as what? P by T ratio. What does P refers to?
Precision error.
Precision error. T refers to tolerance provided by the customer. Precision error is sum of repeatability error plus reproducibility error.
Yes, sir.
Tolerance is USL minus LSL. Now, this P by T ratio, now you have to multiply by 100. Why should we multiply by 100? We get it in terms of percentage.
Percentage.
We get it in terms of percentage. This percentage is known as gauge R and R. What is this known as? Gauge R and R. This gauge R and R must necessarily be less than or equal to 10%. Are you seeing that in the chat box? Gauge R and R?
Yes.
Gauge R and R refers to gauge repeatability and reproducibility. It is always expressed in a percentage. What is gauge R and R? Gauge R and R is gauge R and R is nothing but what?
Precision divided by tolerance into
P by
100.
T ratio multiplied by 100.
100.
A gauge under. This gauge under, if you could bring it below 10%, you have an excellent measurement system, for your data collection activity in your project. You should be happy about it. Suppose in unavoidable situation, a gauge R and R of
Up to 30%, some companies they conditionally they accept.
Yes, 10 to 30% is conditionally acceptable. What is the condition we can accept 10 to 30% error? Can one of you tell me based on your experience? What is the situation under which 10 to 30% error is also acceptable?
You should be above control limit.
We cannot
and
use
within
that
specific
instrument
limit.
for the. We cannot use that instrument for the closer tolerance. We can use to check the tools and any wide tolerance part we can check.
Correct. You have come to the point. Very good. If the tolerance is wider, your process will have a higher capability. That is the point, isn't it? For a wider tolerance, the same process, will be having a higher capability. But if the tolerance given by the customer is made narrower, then the capability will be lower. So you have to check the process. You have to consider the process capability as well. If the process capability is really higher, then second condition is also acceptable. When the second condition is acceptable, 10 to 30%, if the process capability is on the higher side. But we are going to talk about the process capability, only, little later. They are nothing but what? CPCPK. They are nothing but what? CPCPK, right? Whenever your CPK, if CPK is more than 1.67, 10 to 30% GRR is acceptable. Do you all understand? All of you, do you understand?
Yes,
A
sir.
GRR
Yes, sir.
value of 10 to 30% is acceptable if the CPK of the
CPK
process
value
is
greater than 1.67.
greater than 1.67. If that is 1.6, if achieving 1.67 itself is a problem, then it is better to stick to the first condition, below 10%. But in any situation, GRR value more than 30% is unacceptable. Is this concept clear to all of you? This is called gauge R and R study. And there are certain additional procedures, protocols to be maintained while conducting a GRR study, gauge R and R study.
So what is CPK?
Yeah, that is still pending. I have to teach all of you. CPK refers to process capability index. CPK refers to what? Process capability index. And I will explain. It's still not explained. So, but since the terminology is required, I used it. So GRR of 10 to 30% is acceptable only if the CPK value for the same characteristics is more than 1.67. Okay. So all of you please note, so far we have ensured our measurement system is consistent. And in order to ensure measurement system is consistent, there are certain procedure to be followed. I'll tell you, the few important guidelines and remember it. It will be very helpful. When you want to perform a gauge R&R study, please note gauge R&R study is a pilot data collection. It's a pilot data collection. It's not actual data collection. Before proceeding with the data collection, you have to do a pilot data collection. And how to select the appraisers? You can randomly select the appraisers from whomsoever you will be involving in the actual data collection. If there are only 2 people available, you involve both of them in your pilot data collection. If there are 20 people available and you don't know whom you will pick, then randomly you can select appraiser, point number 1. And similarly, for conducting the GRR study, you need a minimum of 10 samples. How many samples? 10 samples are required. Minimum of 10 samples required. And each sample must be measured by each appraiser at least twice. Do you understand? Imagine there are 2 appraisers, 10 samples. Then each appraiser should measure each sample minimum how many times?
2 times.
20.
So measuring the same sample 2 times is known as replication. Is known as replication. A minimum of 2 replication is required. Otherwise, you can't estimate repeatability error. That is the point. Are you with me, all of you? We want to somehow calculate, quantify the repeatability error for each appraiser. Similarly, overall, we want to quantify reproducibility error. So for that matter, every part will be measured by every appraiser. And every appraiser.
Maximum any limit is there? Minimum two times? Is there?
Minimum 2 times and maximum there is no limit. But 3 times is fine.
3 times
2 or 3 times is enough. Right? But you can, if you have more time and you want to be very accurate, then you can slightly increase. But 3 times is ideal.
Okay.
So there are certain things we discussed right now. We need 10 sample parts and appraiser 2 or 3. 2 or 3. An appraiser selected randomly and each appraiser, each part minimum 2 times.
2 times.
So imagine 10 parts, 2 appraiser, each part 2 times. 10 into 2 into 2.
20 times.
10 into 2 into 2 is 10 into 2 itself is 20. And again, there is one more 2. So 20 into 2 is 40.
40 times.
40 readings have to be produced by your team. And then, with the help of the 40 data points, we will calculate GRR value. We will calculate what? Gauge R&R value. Are you with me, all of you? Clear?
Yes, sir.
And I want to give few more tips to all of you. You have to select minimum 10 parts. And while selecting those 10 parts, and make sure you cover the entire, tolerance range. From lower spec to upper spec, you cover, the 10 parts. Do you get my point, all of you? From lower spec to upper spec, let's say 99.5 to 100.5. I want you to select samples ranging from 99.5 and up to what? 100.5. Are you with me, all of you?
Yes, sir.
Are you
Sir.
getting this point? Yeah. Now that I'm sharing my screen because I have already opened a Minitab software. So I can type here. LSL is 99.5 and USL is 100.5. Now, how many samples you must take? 10 samples.
10.
This 10 samples must cover the entire tolerance range. The 10 samples must cover the entire I will say spread of tolerance. I think all of you are able to understand the language. So samples must cover what? The entire spread of the tolerance. Now, samples closer to the central value. You know what is central value?
Mean.
The midpoint of USL and LSL. Correct? Samples closer to the central value are called good samples. Okay? Similarly, your samples can be closer to the specifications also. Yes or no? What are specifications? Upper spec and lower spec. These samples are called bad samples. All of you, do you understand what are good samples, bad samples? Please confirm.
Yes.
Do you understand? Good sample means what?
Yes. Close to mean.
It was near to mean value.
Close
100.
to the mean. Close to the mean or good sample and closer to the spec are bad sample. You have to separate them. You should know the ratio of good sample versus bad sample. It can be 50-50, it can be 60-40, but you should know. Do you understand, all of you? These are some preparations you have to do while conducting a gauge or under study in your workplace. Okay. Now, good sample, bad sample ratio is known, and 10 samples are selected minimum. A replication of 2 is selected, and number of appraisers selected. Now, I will show you after generating these 40 readings or whatever readings, how to do the calculations or how to use software like Minitab and then generate the gauge R&R value, right? So I'm
Sir, one
already there.
clarification. Sir, one clarification here, just to understand. So when you
Please.
say sample closer to specification, is called a bad sample. So that means actually you mean that beyond the boundaries, you mean specification.
Yeah, see, specification means it is still within the boundary only,
Yes.
but still, it is not what to say. Quality wise, it is not closer to the target. Though it is, within the spec, but still the quality of part produced closer to the targeted value and the quality of the part produced closer to the specifications are different. Yes or no?
Yes, sir. Difference are there. Yes.
Yeah. Like if we say the pass mark is
But still
60.
both are acceptable by customer because it's within the specification, right, sir?
Okay, we say pass mark is 60. So
Okay.
you are scoring 62 marks, but another bright student is scoring 95 marks.
Correct.
And I cannot say both are same
Yeah,
level
both are
of.
not same. Both are same, but both are pass. But both are pass.
Both are pass, but they are not same. The
Okay.
95 marks, yes, he really worked hard and he probably acquired more understanding about the subject. But 62 is also pass, but I cannot consider it equivalent to what 95. Not possible. Yes or no?
Correct. Correct, sir. Correct.
Similarly, of all the 10 samples are acceptable samples only because all of them are within the spec.
Okay.
So now at the center is the targeted value. So parts closer to the center, certain percentage. Parts closer to the spec, certain percentage. You need to fix it and choose it in that manner only. And this information should not be shared with the data collectors.
Okay.
If
So
you have
why we are selecting the instrument should capable of detect all the entire tolerance spread, the instrument should capable of detect. So that's why we are selecting it, right, sir?
You're right. Your instrument should perform in the same manner from the lower spec to upper spec, the whole range. Your instrument should be stable throughout the entire range. This is called linearity. Good that madam raised that point. This is called what? Linearity. Linearity is very important. Your instrument, sometimes what happens. Say for example, 7 o'clock we started, and you are very energetic at 7 o'clock. But at 10 o'clock and 10:15, your energy level will be low. Yes or no?
Yes, sir.
It's not good for learning. Same manner, your instrument from lower spec to upper spec, it should be able to maintain the same level of bias. That is called what? Linearity. But this data can be used to check the linearity as well. But our idea is now very simple. We are going to check whether our instrument is able to separate the good and bad correctly.
Okay, sir.
Our definition of good is parts closer to the target or parts closer to the midpoint of spec. Definition of bad part is
Closer to the
closer to the
specification.
spec.
Specification. Okay.
Finally, I will plot this point in a X bar chart. When I plot this point, the data points in an X bar chart, the ratio what we maintained, should be should be visualized in the graph. For that purpose, the good bad ratio is created. Now let's do a small
Okay. Thank you.
study. Yeah, small study using Minitab. Are you seeing my Minitab screen, all of you?
Yes, sir.
Yes, sir.
So you can go to stat, you can go to quality tools, you can go to gauge study, then you can gauge study, then you can come to create gauge R&R study worksheet. Stat, quality tools, gauge study, gauge R&R study worksheet. You click that. Now number of parts. Minimum is 10, but you can have more also, nothing wrong, right? But the minimum should be how many? 10.
Yeah.
Number of appraiser can be 2, can be 3. Suppose you know the name of the appraiser. Let's say when you say 3, now the name of the appraiser. First appraiser is Ramu. Second appraiser is Somu. And the third appraiser is Vasu. Right now we appointed 3 appraisers, right? And now these 3 appraisers are going to measure the 10 parts 3 times each. Now 10 into 3 into 3, how much? 10 into
90.
3 into
30,
90.
90.
90 readings we are going to generate. And here is the order in which you must conduct the study. This is called random order. Now the order in which our appraiser must measure the parts is decided by Minitab randomly. Randomization. Now measured value or measurement, I would say. Measurement. And now the first reading will come from Ramu. Ramu will measure part number 1. And whatever reading comes, you have to type here. Some reading you have to type here. Then again, Ramu will move to part number 5. But while making the measurement, Ramu will never know he is measuring, the part number, should be masked. Are you getting my point? The appraiser should not be able to identify the part number. Is it possible you can do the exercise in that manner?
Sir.
Yes, sir.
Possible or not, all of you?
Yes, sir.
So you have to hide the part number. They have to measure. So Ramu will measure and will give his 10 reading. And then the Somu will come and he will generate 10 reading. And then Vasu will come and Vasu will generate 10 reading. Again Ramu will come and again your Somu will come and again your Vasu will come. Do you all understand? And one more, and the third cycle is again Ramu, again Somu, and again Vasu. So There are 3 cycles of measurement producing how many readings? 90 readings.
90 readings.
Once the 90 readings are generated, you can convert that into a gauge order value. So in order to show you, how the report will look like, let me open a worksheet which already has, some data. So I clicked file and then open worksheet. Then see here, there is something written here. Look in Minitab sample data folder. Click here. Go here. Just type gauge. You will get this file. Gauge AIAG MDW. Open this. You say OK. Open this and you say OK. And now, are you seeing the readings, all of you? Measurement also available.
Yes, sir.
Part number, operator, measurement, 90 readings are available. Now with this reading, I'm going to perform a gauge order study or gauge order analysis. Go to stat, go to quality tools, come to gauge study. Now go to gauge order study crossed. Crossed means parts are common across the appraiser. 10 parts. Totally, how many parts we have? 10 only. The same 10 parts are measured by operator A also, operator B also, operator C also. Such a study is called crossed. So I choose crossed. Now part number. Where is part number? C1. Select. Then operator. C2. Select. Then measured value. C3. Select. And you can choose any method, no problem. Then importantly, go to option. Here you have to either tick this or tick this. If you know both upper spec and lower spec, then you can tick this. If you at least know the difference between upper spec and lower spec, then you can tick this. Now I know the difference between upper spec and lower spec. The difference is how much? 12. Okay, I type 12. So the tolerance is defined. Now the precision error, Minitab will calculate itself. So I give OK and one more OK. Now you got this graphical output generated, which will throw light on the root cause of the error. Now I minimize time being. Now I want you to come here. So this is the table we need to refer. You see, this is the table gauge R and R. And there are some more tables available. You can ignore. Always use the last table. In the last table, see here this one. First row. First row. What does it read? Total. What is it reading? Total gauge R and R, isn't it? Now tell me, total gauge R and R is how much?
15 point.
15.1.
15% is conditionally acceptable. You know what is the conditional acceptance?
Greater
Right?
than 10.
Conditionally acceptable. 10 to 30% is conditionally acceptable. Yeah, but less than 10% is measurement system is true. See here now, if you want to reduce this 5%, if it is okay, then steady you can continue. Or if you want to reduce this 5%, then you may have to refer to the graph. In order to again pick up the graph, you have to click this graph icon. Yeah, graph icon. This is the graph. If you go through the graph in detail, you will be able to understand the root cause. And now see here, 3 colors are available. I don't want you to see all the 3 colors, but you should see only the yellow color. You know why? Because for the yellow refers to
Tolerance.
tolerances value. We gave the tolerance, so yellow only you should look at. There is no point of looking at red and then blue. Just ignore. Look at only the yellow. This is the part to part variation. All of you, do you know what is part to part variation? The variation produced by your process. Part to
Variation
part
within the 10
variation.
part.
Yes, variation in the 10 parts.
10 parts.
The 10 parts are produced by the process. So the yellow color bar, this bar refers to part-to-part variation, also called as process variation. We want to control this. But a certain percentage of the variation, what we observed in our experiment, has come from the measurement system itself. That is what you are seeing here. Can you see here, all of you? Because of the poor consistency in the measurement system, some error is populated. That is called gauge R and R. That value is split into repeatability error and reproducibility error. And we get a visual, clue about part-to-part variation or process variation and gauge R and R value. This is repeatability error. This is reproducibility error. Are you with me, all of you? The first graph.
Yes, sir.
Yes, sir.
Yeah.
The cumulative
Then
of repeatability and reproducibility adds up and give the gauge R and R. Is it so? It's like repeat value plus reproduce value is the
you
sum
see
of
here, everything is here. Repeatability is this much. Repeatability is 10%.
reproduce.
Reproducibility 11%.
Then
But total
21.31.
gauge R&R is 15. Please
Oh,
note
so it's not
10.
direct.
Yeah. See, please note 10 plus 11 is 21.
Ah,
But here you will only have 15. The
okay.
reason is the repeatability error and reproducibility error. When we sum up, we have to do a statistical sum, not an algebraic sum.
Okay.
Algebraic sum is
Yeah, understood.
merely, you can add merely. But a statistical sum means there will be a specific formula available, you have to use it. You all understand? That is why it won't tally. 10 plus 11, you might think
Yeah,
it
yeah,
is
correct.
21, but it is not so.
And also,
So
we are dividing
yeah,
it by tolerance given by the
that will
customers,
come.
right?
That yeah. See,
That will
the
also add.
gauge R and R is repeatability error, reproducibility error. You see here, the standard deviation is calculated for repeatability separately. Can you see what is the standard deviation here? 0.19. Are you
Yes.
seeing 0.19?
Yeah.
This
Yes, sir.
0.19 is multiplied by 6. When I multiply by 6, I get the estimated error. And this 6 times error, 6 times standard deviation is divided by tolerance. So it becomes what? 10%. Similarly, here it is 15%. So there is total error 15, repeatability
10
error 10, reproducibility
reproducibility.
error 11, and ultimately what we need is only this one right now. It's a conditional acceptable scenario. So you know what to do also. Now, if you look at the graph, you will get to understand the root cause. Can you see appraiser A and appraiser B and appraiser C visualized separately? All of you? Are you seeing appraiser A, B, C? A
Yes,
is
sir.
written
Yes,
here,
sir.
B is written here. This is called R chart, range chart.
Range chart.
R refers to range. This graph is helping us to understand the operator repeatability. Now look at the graph and tell me whether A is, the repeatability of A is good or B is good or C is good.
Range A is good.
A is good.
B is C is
And
next level. B is bad.
yeah, we seem to have some out of control points. Variations are very high. Probably if you could help B improve the consistency, that will bring down the repeatability. Do you understand? If you help B improve the consistency, the overall repeatability error will come down.
Yes, sir.
Now X bar chart. Look at the X bar chart. Here you see certain points appearing outside the control limit, certain points appearing inside the control limit. Are you noticing here?
Yes, sir.
Here
But no
comes the
much
red.
variation between appraisals. On
We'll
inference
come to know
broadly.
between appraiser, we can see in box plot. Now here the purpose is secretly we maintain the
Process
ratio. Yes or
variation.
no?
The process variation, sir.
Yeah. Secretly we maintain the variation, isn't it? Good bad ratio. We remember
Yes, sir.
if the good bad ratio is 50-50 or 60-40, A similar ratio must appear here.
Okay.
If this is not appearing, there is a problem, in your measurement system, because I only mixed the good bad, isn't it?
Correct.
So that good bad, at least a closer, replication should happen here. Now the operator, whether the operators are agreeing to each other, that you can see in the box plot. Operator A, operator B, operator C. First of all, you should know what a box plot is, right? You see, there is a blue color box, there is a vertical line, there is a vertical line. The vertical line is called, like your, what do you call? Whisker line. The vertical line is called whisker line. There are two whiskers and there is a blue color box. This bottom line is called, quartile 1. The mid line is called Q2. This line is called Q3.
Q3
And there is a circle with the plus symbol that is called, your
mean.
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 So mean value for appraiser A is here. Mean value for appraiser B is here. Do you see them connected by a horizontal line or are there any inclination? The amount of
Slight
inclination.
Slight
inclination.
inclination. Otherwise,
Yeah,
it's
the amount of inclination is proportional to the, what do you call, the amount of reproducibility error. More inclination, more error.
Mm.
Okay. Now A and B, there is not much error.
Not much difference.
But when you look at C, his average is pulled downwards. So if you somehow help C align with the A and B, the reproducibility will improve, and as a result, the overall gauge R&R will improve. Okay. So there are so many graphs here. We spoke about 4 graphs, and we will certainly try to understand the remaining 2 as well. But right now, I think you got some idea, right? How to conduct the gauge R&R study, how to generate data, and then how to use Minitab and generate the report. And mainly, if you go look at the session window, the GRR value here should read below 10%. That is the requirement, GRR value here in this line. If it is not below 10%, if it is found to be above 10%, above 30%, what is the exact root cause? You can find out by referring to the what?
Graph.
Data and the graph. There are 6 graphs over there. We discussed about 4, and probably we'll also discuss the everything one more time when we come. So this is how the gauge R&R study must be conducted, and the what do you call, the measurement system is validated. What is getting validated? Measurement system. And over and above, you have to ensure your measuring instrument is calibrated. Yes or no? While conducting a gauge R&R study, the measuring instrument should be a calibrated measuring instrument. Yes or no? So you have to check the calibration validity even after MSA. And you have to ensure the measuring instrument is stored properly as per the storage instruction, used properly as per the usage instruction. If you do all these things, then whatever gauge R&R value you see, the same will be the amount of bias. Are you with me? Do you understand, all of you?
Yes,
If the
sir.
gauge R&R is 5%, then the total bias will also remain at 5%. But if you don't understand, the disciplinary, the disciplines I mentioned, like instrument is not properly calibrated, and then, people don't know how to use the instrument, and instrument is not stored properly. If these issues are going on, then the total bias will be higher than the GRR value what you found. Are you getting my point? Very important. So if the GRR is controlled to below 10% and you have a valid calibrated measuring instrument and people are aware of how to use the instrument, how to handle the instrument, how to store the instrument, then no worries. Your the GRR, whatever is the percentage you see in the GRR, the same will be the bias, percentage bias. Are you getting my point?
Only one doubt, sir. GRR, if it is well within control, then it's not directly proportional. So bias also will be under control. It's not that.
Let
It's
us
not
say, let us say
related.
GR, let us say GR and gauge R and R value is
5%.
5% only, 5% only.
Correct.
That means the bias expected will also be 5%. Bias expected will also be 5%, right? But if you doubt whether the calibration is okay or not, whether people are no clear with the procedure or not, then you have to do a study on bias separately. Do you understand, all of you? Study on bias have to be conducted separately. If if you doubt on calibration and all those things. People might simply say, they themselves take a printout and display the calibration certificate. If these things are happening, then you may have to do a bias study. But for conducting bias study, you need standard parts, not ordinary parts. For conducting bias study, what parts are required? Standard parts are required.
What do you mean by standard parts? It's an instrument, or what is standard parts means? Reference
It's a
sample?
reference part. For the reference part, the measurement is already known. Measurement is already known. Maybe some standard pieces are kept,
Reference sample.
or otherwise you have to establish standard and then use it. So standard pieces must exist, and then you can ask appraiser to measure the standard part, each standard part, some multiple times, right? And that will throw light on the bias. Whatever bias you calculate and whatever gauge R and R you already calculated, they should be equal. You understand, all of you? If they are not equaling, then there is something, problem with the instrument. You have to recalibrate and all those things you have to do. So this is MSA for continuous data, and I don't want to drag your time further. So don't worry about the topic that is not covered. I will certainly cover it with all of you, right? Be rest assured, it will be discussed. So what are the topics we will be discussing pending today? Process capability analysis. Though we tried to speak about it, in the first session itself. First session is, comparing control limit with the specification limit. Do you remember control limit and specification limit comparison? Yes or no?
Yes, sir. Yeah.
Yes,
If
sir.
your control limits are inside the specification limits, your process is capable. If your control limits are outside the specification limit, there will be a failure. Definitely there will be a problem. So this I will explain to you in the next class. So far we understood what is statistics, descriptive, inferential, normal distribution, properties, isn't it? And then we also spoke about MSA, in particular, gauge R&R study. And there are a few more things like your CPCP study. And there is one other thing called a AAA. One other thing called a AAA. You know what is AAA? AAA stands for Attribute Agreement Analysis. AAA will be the choice if the data in your hand is discrete or attribute in nature. All of you, do you know what is discrete or attribute data?
Yes, sir. Yes or no?
Mm.
No go. This kind of.
So non-numerical, yes or no, go, no go, pass, fail kind of thing. If that is the kind of data you have, then you need to perform a study called attribute agreement analysis. So I will talk to explain those things, slightly later when we meet again. Okay. So is that today's class helpful?
Yes, sir.
Yes, sir.
Yes, sir. Very good.
So then that's all for the day. Thank you very much for your effective participation. We'll meet again.
Yeah. Thank you very much, sir. Good night.
Good night, sir.
Thank you, sir.
Welcome.